Today we're going to talk about writing absolute value equations using our transformations. We're going to use our foundation of the parent absolute value function and our function notation of transformations to combine and write equations given certain transformations. Now, when writing transformations, we do want to work in the order that the transformations are given to us. I know that we usually work in a different order when we're describing equations and the transformations made from the parent on those equations. But when we're writing equations, we want to work in the order the transformations are given to us so that we write the correct equation in the end. If you work in a different order when writing, you might be describing a different equation. So you really want to be careful about that. Our first example asks us to start with our parent. The parent absolute value function equation is f of x equals the absolute value of x. Then it wants to take that parent function and shift it left 7. In function notation, this notation says to replace x with x plus 7 in our function. Right now our function is our parent, so I simply, inside the absolute value bars, replace x with x plus 7. A horizontal stretch by 4 actually works with the reciprocal, so I'm working with a 1/4 because it's horizontal, and it's multiplying to x on the inside. So function notation-wise, this is f of 1/4 x. This says to replace x with 1/4 x in the function f. We want to use our most recent version of the function f. And the last transformation here is to reflect about the x-axis. That means a negative on the outside of the function notation. In words, that notation says multiply the entire function by a negative. Our entire function is one term, the absolute value term. So that actually just puts a negative outside the absolute value. You never want to distribute a negative over an absolute value sign. When you've finished all your transformations, to write the equation, you want to give it a different name. Because we started with f of x, I'm going to call this one g of x and just say g of x is equal to negative absolute value 1/4 x plus 7, close those absolute values. This is the function I got after I performed all of those transformations. Now, here's the thing. It is important that you use the function notation. The function notation is going to help you, especially when you say the words that I'm saying. When you're saying like replace x with this, multiply the whole equation, things like that will help you get the correct equation in the end. It is tempting to skip the function notation and just try to write the equation, but you are more likely to make mistakes that way. So you are really, 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 really encouraged to show your work like I am in this video. Number 2, we're starting with the same parent. So I'm going to write the parent over here, f of x is equal to the absolute value of x. A horizontal stretch by 4. This is the same transformations as example 1, just in a different order to look at what would happen. Because remember, when we're writing absolute value equations from transformations, we have to work in the order the transformations are given to us. So a horizontal stretch by 4, function notation is f of 1/4 x. That notation says replace x with 1/4 x. And it looks like that. If we're shifting left 7, that's adding 7 on the inside. This says in your function f, replace x with x plus 7. I notice that my x here is affected by that 1/4 though. So when I replace x, I'm going to use parentheses to show the substitution. Like that. When I use parentheses, it's very clear to me that I need to use a distributive property to simplify this inside of my parentheses, resulting in this. If you don't use your function notation, you're more likely to miss a distribution that like this. And then our last transformation is to reflect about the x-axis. We talked about how function notation-wise, this is multiplying on the outside by a -1. So this says multiply your entire function by -1. Our entire function right now is one term, the absolute value term. So that negative is going to go right on the outside. So here we have the same three transformations, but this equation is different than our g of x equation. I'm going to name it something other than the two I've already used. Let's call this one h of x. And this is my final answer. We're going to change it up this time. We have different transformations, but we are starting with that parent. Our first transformation is a shift up 12. In function notation, you add 12 on the outside. This says add 12 to the end of your function. Well, right now, our function is the absolute value of x, so that's going to change into the absolute value of x plus 12. We have a vertical stretch by 4 that is multiplying by 4 on the outside. When we're on the outside, we don't need to worry about the reciprocal, so that is 4, and that's okay. Notationally, this says multiply your entire function by 4. In this case, we have two terms. We have an absolute value term and a 12. That's two terms. So we actually have to use parentheses and multiply that entire equation by 4. That's a distributive property. Now, we never want to multiply inside an absolute value with an outside number. So to write that first multiplication, we would actually do 4 times the absolute value of x. That's how we multiply that first term. If you multiply both the outside and the inside, then you're multiplying twice, and that doesn't make sense. You really, really don't want to distribute over absolute value bars. And then we have to do 4 times 12, which is 48. So this is the most recent version of my absolute value right now. Our last step is to reflect over the y-axis. That is a negative on the inside here. Notationally, this says replace x with negative x. Now, there's nothing affecting our x on the inside right now, so I can simply just replace it with negative x to get my final answer. That is my last transformation, so this is my function. We give it a name and call it a final answer. I'm going to call this one p of x. And number 4 has the same transformations as number 3 in a different order. Again, we want to work in the order given to us because we are writing different equations. So our parent, same starting point, absolute value of x. So a vertical stretch by 4, function notation-wise, is multiplying by 4 on the outside. Right now, our equation is simply the absolute value of x, so we have 4 times the absolute value of x, keeping that multiplication on the outside of our grouping symbol. Up 12 notationally is f of x plus 12, adding 12 on the outside. That says to us, take your function f of x, which is 4 plus the absolute value of x, and add 12 on the outside. So we would just simply put plus 12 at the end of this. Our last transformation is to reflect about the y-axis. That is a negative on the inside. Notationally, this says replace x with negative x. X is all by itself, so I'm confident in my direct substitution that my equation would look like this. Clearly different from number 3's equation because of the order the transformations were given to me. I know that I want to name it something different, so we're going to say the equation m of x. So once again, when writing equations, it's super important that you work in the order the transformations are given to you. It is highly encouraged that you use the function notation and think about what the function notation is saying to you in words. That'll help you with cases like, when do I have to distribute? When do I not have to distribute? If you're showing work, you're less likely to be confused and make mistakes of distributing when you're not supposed to be, or the other way around.